welcome to Start Science, and I'm hoping that everyone during this pandemic is staying safe and healthy. Today, I'm going to be talking to you about the water cycle, and just to let you know, this one is created by the Start UTSC. So before we get started, let me just tell you a little bit about myself. My name is Linojah, and I'm a second-year student here at the University of Toronto Scarborough campus, and I'm currently enrolled in the Life Science program. Just a few fun facts about me. I currently work in the pharmacy as a pharmacy technician. I got that job at I believe, the second semester of my grade 11 year, as I worked for co-op, and then eventually I did get hired. So that is my part-time job at the moment. So today I'm going to be talking to you about the flow of life, because water cycle, flow, just a little joke. So our agenda for today is going to be the lesson. So I'm going to talk to you about the water cycle, obviously. I'm going to go into a little bit of detail about each parts of it, as well as some ways that the water cycle affects our lives or how we affect the water cycle every day. And then we're going to have a little activity time. So it's going to be including a material check, safety check, and then the actual desalination experiment itself. So before we actually get to any of the fun stuff, we got to learn the basics, of course, in order for us to be able to relate to the actual activity, right? So today we're going to be talking about the water and its importance. So the first thing that is so essential for water, and you will hear it anytime from your doctor, drink lots of water, stay hydrated, it's because water equals to better health, and it's also part of our cell composition. So what cells are essentially the building blocks of life. So you are made of millions and millions of cells, okay? And so in order for these cells to work, they need water because 70% of the cells are made up of waters. So some functions that the cells have in your body is that they absorb and assimilate minerals, vitamins, and other substances. They help regulate body temperature. So if you go to the doctor with a fever and the doctor tells you stay hydrated, drink lots of fluid, it's because essentially this water will help to bring your body temperature back to a normal state, essentially helping you get better. It also flushes out toxins and waste in your body. It acts as cushioning for joints and muscles. Next up, we have Earth's composition of water. So we know that the Earth is made up of water, right? So actually the total volume of water on Earth is 1.386 billion kilometers cubed. Think about that. That's a pretty huge number. But let me make it into a better context for you to see why we need to save water, because there isn't actually that much on Earth. So we know that the Earth's surface is about 71% water. Of that 71%, 97.5%, that's a huge part of it, is salt water. Only 2.5% of it is fresh water. And of that 2.5%, only 0.3% is liquid form. So that, if you look at it, that's not a lot of water that's in liquid form usable for us, right? And of all the water on Earth, only 1% of that water is suitable for human use. So if you really think about it, saving the water, such an important part of life. Next up, we have hydroelectricity. So if we think of hydroelectricity, it's basically the motion of water in order to conduct electricity. The word hydro itself means water. Electricity is also obviously conducting some type of flow in order for something to happen. So it's basically the motion of water conducts electricity. It's in the word itself. So this is important because obviously it is more efficient. With greenhouse gases, pollution, polluting the earth is obviously polluting the water too. So using this type of electricity source essentially helps us save water, have a greener earth, all sorts of important stuff. So less pollution and saves energy. Next up, let's do a little recall before we go into more detail about the water cycle. So what are the 3 states of water? I'll give you a few seconds. Okay, so they are solid, liquids, and gases. Those are the 3. The change between these 3 are essentially the water cycle. So now what are some steps of the water cycle before I go into detail? A few seconds. So we have precipitation, condensation, evaporation, and collection. So this is just an overall view of the water cycle. You can see that the water cycle is a continuous cycle. So it starts at one point and goes from another point to another point, and back to that same point. So there's no break in this sort of cycle. So obviously we have condensation, precipitation, collection, evaporation. So the first part of the water cycle that we're really going to be looking at is collection and runoff. So basically, you got to think if this water is raining down, it's obviously got to be collecting into one place in order for it to be able to go back up and recycled. So then this water essentially comes from lakes, rivers, oceans, any type of body of water, and that's where it kind of collects in order to prepare to evaporate. The water from land runs off into these bodies of water, and some of the water actually collects into the soil and eventually it goes into the ocean. There's also another part of this that is not as significant, but it's also there. So I'm going to mention it to you. So we have transpiration. Transpiration is basically when the plants have water in them, and that plant water is essentially also kind of collected and waiting for it to be evaporated. So after collection and runoff, we have evaporation. So we know that when we have a solid, so like an ice cube, if you heat it to a certain point, it turns to a liquid. And then after a liquid, it turns into a gas, right? So this is what the evaporation is. It's when we have this liquid form of water and you add heat. So if you boil like a kettle, you'll see that a gas is coming out of the kettle. That is essentially evaporation of water. So this is when the water rises to the sky in order to form clouds. Next up, we have condensation. So condensation is basically the water vapors that comes up after evaporation and it cooling down in order to change into water, and it forms clouds. So the air is cooled to a dew point. So a dew point is basically the temperature at which condensation occurs. So obviously, when you heat up water, turns into a gas, you need it to cool down. So you need to hit a certain temperature up in the atmosphere in order for it to cool down and become either a solid again or a liquid again or some form, depending on the temperature of water, right? So next up, we have precipitation. So it's a weather condition where something falls from the sky. So precipitation is basically rain, hail, snow, anything like that. That is called precipitation. So this is basically when the water cools down, and depending on the temperature, it'll fall down from the sky eventually. So you know when you see like gray clouds up in the sky, it's because there's so much water up in the sky that it needs to be precipitated. That's how I look at it, at least. So then, obviously, the colder the temperature is up in the atmosphere, it's going to snow or hail, which is what happens in the winter. And the warmer it is in the up in the atmosphere, it's going to rain. So it's going to come down as rain rather than snow or hail. So obviously, we every day affect the way this water cycle is occurring, right? So there's some points like global warming. So this is an increase in the rate of evaporation into the atmosphere, or it's also essentially, so let's say we take water from one lake. We take all the water, there's too much water that's been evaporated due to global warming, which is basically there is an ozone layer around the earth, right? The earth has an ozone layer, and that ozone layer keeps the heat that comes in and goes out, comes in and goes out. So it keeps that constant balance. So the amount of heat that comes in, it also gets released. So there's not too much warming of the earth. But what's happened over time is through greenhouse gases, pollution, all that has led to a hole in the ozone layer. So a hole in the ozone layer essentially means that any heat that comes in cannot go out. So it's being overheated, and then the earth becomes overheated. So that's when some things like evaporation increase, because evaporation, as we know, is when water is heated to a certain point, right? So when the water is heated to a certain point, you see that the evaporation, the more heat, the more evaporation, because more heat means more water is going to become into a gas state. So then this means if you have one lake and you take a lot of water out of that one lake, you're going to leave that lake with a dried out area. So there's essentially going to be no water there, which you can see in the first picture actually. So you can see that there's like water taken out of that land and taken over to another land. But sometimes if it's taken over to another land, that means that we might have too much water in another land that can actually lead to things like flooding. So this is actually how the cycle works in order with drought and flooding. This is how that balance actually works. Next up, we have pollution. So pollution can affect any aquatic life in those bodies of water, right? So if we affect those bodies of water and we kill those animals, essentially that's damaging our ecosystem, that's damaging our water cycle and any sort of path that comes after that. And it can also disrupt the natural food chain of life. So let's say there's a fish that only eats a certain plant, but then there's not enough of that plant growing. It'll kill the fish, and whatever eats that fish will also start to die because there's no fish in order for it to eat. So essentially, it breaks that chain of the water of the food cycle. Sorry. Next up, we have dam construction. So you'll see dams that are built up in order to reserve water or for some other type of purposes. Those actually increase the risk of floods because creating that sort of dam, it builds up the water. And say there is a crack or a break or some sort of malformation in that type of structure, it can actually cause the water to flood the area around it. And it also produces greenhouse gases while it's working, in which can essentially affect and add on to pollution. So you can see in the bottom picture actually how the water is being polluted through that could maybe be a dam that's creating that, or a factory, or some sort of a building that's causing that type of water to run into the lakes. So before we go on to our experiment, I hope you've learned a lot today from me. But here's some fun facts actually. So you know how I was talking about transpiration earlier? That's essentially plants sweating. So when plants sweat, the plants are heated and then the water evaporates, and that comes part of the water cycle as well. So water cannot be made by mankind. So you know how I told you we have the certain amount of water on Earth? That is all the water we get. We cannot make water. That's just how it is. And that water gets recycled and reused. And that's why we say it's essentially important for us to save water. That's why they say turn the tap off when you're not using it, or fix a leaking tap. That is why. So, and then next one is that sun is actually the driving force of the water cycle. So if you think about it, the water cycle, how the water moves up, evaporates, comes down, everything is on the sun because the sun is the source of heat, right? So without heat, how is the water essentially going to evaporate? It's not. Exactly. So that's how you got to think of how the water cycle works in coordination with the sun. Next up, we have the fact that water can be stored in lakes, glaciers, snow caps, and below the ground. So, like I told you, groundwater can essentially sink into the oceans and can be evaporated from there. But if you think about it, glaciers, snow caps, anything like that, it's frozen water, right? So that's also where a lot of our water is stored in solid form because it's not liquid form, it's not usable to us yet. And also, finally, trees are actually made up of 75% water. Can you believe that? To me, that was shocking. It was like this solid structure is made of 75% water. That is crazy. But also, the human brain is made up of 75% water. So that brain up here that's keeping you thinking, moving, all this type of thing, that's made of 75% water. So it kind of makes sense why doctors say drink 8 glasses of water. Make sure you drink lots of water to stay hydrated. It's to make sure that that brain, that body, stays healthy. It's kind of cool if you think about it. And there's also some just facts over here that you can look over. I'll give you a couple seconds. So something that I found really, really cool was the fact that they said we could be drinking same water as dinosaurs drank. That's essentially true because we know that water cannot be made by mankind. So any water that dinosaurs drank, essentially that was recycled, and now we could be drinking that same water. Isn't that cool? Finally, let's reflect on what we've learned today. So I hope that you've learned something. I've tried my best to make sure you guys are taking part of your education, even during this COVID pandemic. So let's go on to the first question. So the first question is identify each of the following as either evaporation, condensation, or transpiration. So heating of a liquid to become a gas, I'll give you 5 seconds. That is evaporation. So the next one is heating of trees in order to release water. I mentioned this one a couple times, so I think it should be okay. That is transpiration. And next up, we have the cooling of water in vapor in order to form liquid. That is condensation. So those are the three that I wanted to really go over and talk to you about. Your next question is, what factor affects the type of precipitation that occurs? So we've talked about how the sun was the driving force, right? The sun was a driving force. What does the sun provide? It provides heat, and heat is also associated to temperature. So temperature is the driving force that occurs and affects the type of precipitation, because if it's really hot, it's going to rain. If it's super, super cold, if there's a point of where it's like freezing, essentially it's going to be in the winter, right? So that's snow or hail or some type of ice that's going to fall. Next up, here's the fun part, okay? We're going to do a desalination reaction today, and then we're going to talk about it and see how that compares back to the water cycle. So our goal today is of heating and cooling of salt water in order to remove any salt or minerals that were dissolved, and we're going to see where those salt and particles go and see what happens essentially, okay? So your material list. So I'm going to just show you what I've picked out for the experiment and what I'm going to be using. So you're going to need a bowl, some sort of bowl. You're going to need a large pot first, just so you can mix your salt water. And then you're going to need a bowl. A large pot. That was your bowl. Sorry, I don't know, I'm getting confused. It's a large pot. Then you're going to have salt. You're going to have water, which I have in here. You're going to have a spoon. You're going to have a boil-safe mug, so essentially glass, something that won't break under heat. You're going to need tin foil. You're going to need ice. I don't have ice because I don't want it melting while I'm doing this, so I'm just going to use this to represent my ice. And obviously a stovetop, because you're going to need to heat stuff. So, but before we get started, we know with any science experiment, there's always a set of safety rules we're going to go through. These rules have been set to us by the Start Science, and essentially I think they make sense and they're very, very helpful in order to keep everyone safe at home. So make sure that you listen to and follow instructions carefully. So anything I say today, make sure that you are following carefully. If you have questions, please contact us before you do the experiment. We do want to make sure everyone is safe during this time. Do not eat, drink, or any sort of that type of thing during the activity, unless otherwise notified by us, unless we need you to taste something. Other than that, please don't. Keep your hands away and materials away from all of the following. So your eyes, your mouth, your nose, your ears, and anyone around you that's helping you, around you, that type of thing. Do not run. No running, especially if there is stuff around you. Regardless, there should be no running during the experiment. Make sure your laces are tied if you're wearing shoes, because you will be at home. Make sure you do not throw materials at other people. This can be a very, very hazardous thing to do. And if you have hair, long hair, make sure you tie that back. And also just stay away from electronics and keep them away from any liquids or heat sources like batteries, wires, any technology, phones. Just be careful with the amount of distance you give between them, okay? So before we get started, I want you to grab a piece of paper and I want you to make this chart for me, okay? So this is called your observations chart. So you're gonna do before the salt was added to the water, after the salt was added, and after boiling. And you're gonna tell me all the observations from smell, taste, touch, what you see. I don't really think we'll be doing smell, but taste, touch, and how it looks. Anything that you think has happened during each of the experience, anything you can get it all. Please write it down in these charts. So let's get on to the experiments. So what you're gonna do is you're gonna start off by taking your salt and just taking a big bowl. It can actually be anything, honestly. And you're gonna add your salt. And then you're gonna take a spoon and you're gonna mix it, okay? Essentially, this should be warm water. The warm water will help the salt to dissolve easier. And you can stir it, and you don't have to stir it till it's all dissolved. You can have a little bit left at the bottom. That's no problem at all. Now, kids, your turn. Make sure you're having an adult help you, because there is a stove that's going to be used in this procedure. Your turn. So you're gonna look at the water. Just make sure you do your observations before we added the salt water. Sorry, I forgot to note that there. But Do your observations of just the water itself, okay? Now that we've added the water, go ahead, dip your finger, take a taste, make sure it's clean water, clean bowl, and examine it. Now write down your observations of what you see of the salt water before we've done anything to it, okay? Now that you've got it, we're gonna take your salt water and we're going to just pour it into the larger pot. Make sure this pot can be boiled on the stove, okay? So this is what I'm gonna be using. You can add one more water, it's just all I had on hand at the moment. And the next couple steps, parents, your help is essential, okay? Now you're gonna place your mug right in the pot and you're gonna make sure that no water gets into the mug. You're gonna try your best to make sure the salt water stays outside of the mug, okay? Next up, you're gonna take your, just grab my tin foil, your tin foil. You're gonna place it over. I've already pre-cut this one so it fits the pot perfectly, but you can do that just to make sure that you don't have anything sticking near the stove. And just make sure you seal the edges, okay? Seal the edges. And also, make sure that you have a little bit of it lowered in the center. So what that means is that you have the pot, right? So there's a slight lowering in the middle, which is where I'm going to place my ice cubes, okay? So obviously you do this, you place this on the stove and you bring the water to a boil, okay? And you're gonna leave it to boil. And once you see that the ice is starting to melt or that there's a significant amount of boil, you're gonna turn it off, okay? And you're gonna make sure that the boil doesn't dry. So what that means is you're gonna make sure that none of the water that's evaporated or condensed or anything starts to sit back to the original position it was, okay? You're gonna turn it off. You're gonna let it cool. Make sure you don't touch it, okay? You're gonna pull off this, so the ice, right, and the tin foil, and you're gonna look at your cup. So essentially now, your cup should be filled with a little bit of water, and your kids are now gonna taste for salinity. So make sure you have your chart available because this part's gonna come in handy. You're gonna look at your chart and you're gonna tell me what you think of after boiling, okay? So after boiling, now let's consolidate. This is the part where we're going to think about how we're going to do this experiment. But before we do consolidate, I want to go 2 slides back now, okay? So back to the materials list. Essentially, all the materials on here, there's not really much you can change or that you can use if you don't have it sitting at home. Honestly, the large pot, you don't need a pot and bowl. You can actually mix the water and the salt in the actual pot itself. It just needs to not be too mixed, that's all. And the tin foil, essentially, it's probably the best idea in order for desalination to occur. But the rest of it is really not that much of there's not really anything we can substitute it for. So I'm really hoping everyone has all this stuff lying around. If you don't, please do contact us and we can try our best to see if there's something we can change for you. But that is what we have for now. Okay, now going back to consolidation. So we're done the experiment now, yay. And I hope you learned something about the water cycle in the process, but let's talk about it. So what part of the water cycle could be understood through this experiment? How does desalination fit the cycle? So I'm going to give you a couple minutes just to look at it, think about it, speak to your mom, speak to your dad, speak to your parent or guardian, speak to a family member, anyone, just see what you can come up with, okay? And it'd be good if you're writing this stuff down as well. Okay, perfect. So let's talk about this now. So what did you notice about the salt water in the actual cup? It was saltier. Good. So this essentially means that the water and the salt that was in the actual pot itself evaporated due to the amount of heat. But since it had that barrier, which is essentially your dew point, if you think about it. So the tin foil, so the water evaporated, hit the tin foil, that was its dew point, and then it condensed, right? And since you have the ice in the middle, the ice is providing the cooling point, so the dew point, in order for that water to condense. So it hits the point where it has the water and the ice, and it falls back down. But since the ice is right in the middle where the actual cup is, it melts, it condenses back into the liquid form, and then it precipitates into the actual cup itself. So any salinity, any salt in that, it would condense back into the cup. So we're looking at 3 parts here. We're looking at four. Collection, which is putting the water in the pot. We're looking at evaporation, is when we heat it and the water comes up. We're looking at condensation, is when it hits the dew point with the ice. And we're looking at precipitation, when it comes back and falls into the mug. So what information supports these results? I actually just explained that in the last question. So just looking at it and seeing that the 4 steps are happening, that's enough to support the information and to support the results of why the water in the cup is salty. Finally, during the experiment, what do you think affects the water's salinity, and what factors played a role in the changes? Okay, I'm going to give you a couple seconds to think about that, and then I'll go over that with you. Okay, so let's go over it. So give it a pause if you need another couple seconds to think about it, but I'm going to give you the answer, okay? So we don't go through too much time. So during the experiment, what do you think affected the water salinity? So the water's salinity was affected by obviously heat and temperature. We've talked about it. We know that's what affects this water cycle at most. So temperature plays a huge part in how saline or how much salinity is in the water. So during the evaporation of the water in the large pot, the water there is evaporating and it's not essentially going to stay there, and the salinity of that water is going to decrease while increasing the salinity of the water in the cup, right? And what factors played a role in these changes? So the factors were heat, temperature, because there was actually heat, and there was actually cooling too. It was just heat, right? So that's the biggest factor that played a role in these changes. So temperature, which is also the biggest factor that plays a role in the water cycle, but also the environment itself too, because it's not an open environment. If you think about it, it's closed, right? It's essentially closed. And if you think about the water cycle, even though it's a huge open environment, it's closed as well, because when it hits those clouds or it hits the dew point, that's its limit. That's where it's set, and it's going to cool down and come down eventually as precipitation. So if you really think about it, we're in one closed cycle, if you really think about it. But essentially the environment plays a big effect too, because in lakes or oceans, it takes a longer time for the water to evaporate because it's a larger area, right? But with my pots, it's a smaller area. It's not going to take as much heat. It's not going to take as much energy for that water to come up and go down. And one thing I also want you to notice and learn from this experiment is that water is not released, or water is not expelled. It's the amount of water I put in is the amount of water I'm going to get out, because it's, again, water is recycled and reused. Just as long as you make sure that your seals were properly tightened at the edges, you should be good. That's how the water should be recycled. These are my references. So I'm hoping you learned something from us today, and thank you so much for engaging in the Smart Science lecture today. And I'd love to hear any questions that you guys have, any clarification that you need, any questions or comments. Of course, you can email us at contact@startscience.org, or visit our website at https://www.startscience.org. Thank you so much for listening.